hand out the notes, I'm going to start by going through some vocabulary. We're starting the actual geometry. And so there's a couple of terms that you should know and know what they look like and how they work and how we label them. So I want to make sure that we're on the same page on that. So I got a quick little video to show you that.
Hi everyone, today is the day we start our first chapter of geometry, and I want to begin by looking at some basic vocabulary of points, lines, planes, and more. And I brought a special guest to help us do it.
Woohoo! This is Vocab Carl here to talk about the most important subject in the world, math, specifically geometry vocabulary.
Let's start with a point. A point is basically a locator to tell us where in the diagram we're looking at. We label points with a capital letter, so I'm going to label this point P.
A point is a place like right here where I'm standing, and I would label it C for corn.
Next is a segment. A segment's going to start at one point and then extend out to another point. So it has a start and an end, and that means that we can measure its length. A ray is going to start at a point and then go off forever in a direction.
So I start off in a point right here and go off in a direction like that forever, like this.
We'll check in with him later.
For a line, we're going to draw an arrow on both sides because it goes on forever in both directions. Lines and rays are not going to have length. Two lines will intersect at a point. So if the black line is the direction I'm going and the red line is the direction Carl's going, then we're going to meet at a specific point. Right here. Unless our lines run parallel, and then we'll never meet. A plane is a two-dimensional surface that goes on forever. So if you think about your XY grid, or a wall that goes on forever, or maybe a cornfield going on forever.
A field of corn that would go on forever, that'd be the most beautiful thing in the world. That's bringing a tear to my eye.
Two planes are going to intersect at a line, and I'll let Corncob Carl show us how that works.
Here's an example of two planes coming together, and they intersect to form a line that goes on forever and ever.
Now, before we go, we need to tell all these things apart, so a quick rundown of the notation. If we've got a point, label it with a capital letter. If we've got a segment, tell me where it starts, tell me where it ends, put a bar over it. If we've got a ray, tell me the point it starts, tell me the point it goes, and put a ray over it. If we've got a line, tell me 2 points on it, and put a line over it. Well, sometimes we might be sneaky and use a lowercase letter to label the line. That's fine.
If I got a plane, that'd keep my arms from being so tired from clapping, because, you know, flying's hard.
Not quite. If I've got a plane, just pick 3 points on the plane. And those are the basic ideas of points, lines, and planes. Thanks for watching the video, and I'll let Corncob Carl sign us off.
Woohoo, kids, this is Corncob Carl signing off. And just remember, without geometry, life is pointless.
I want to start by emphasizing segments. And so, remember, a segment has a start point and an end point. So it makes it different from like lines and rays. I said that they don't have lengths because they go on forever. So they technically would have an infinite length. Versus a segment which has a start and an end. And so I can actually measure its length. So let's say this is the idea that we're going to talk about today. This is the fundamental idea. And it's going to be something called a postulate. And a postulate is something that is fundamental and is kind of common sense that we can assume to be true. So here's the common sense thing that we're going to say is true today. All right? Let's put a point in between those two. So now I've split my segment into 2 smaller pieces. And I know that this piece, this first piece, is, let's say, 7. And this piece over here is, let's say, 3. What's the entire segment going to be? 10. Right? This entire thing is going to be 10. 7 plus 3. Let's do it one more time, just to make sure we got it. If I tell you this piece from here to here is 8, and I tell you this piece from here to here is 5, what's the entire length going to be? 13, 8 and 5. Or, let me work backwards. Let's have this now be 17. And I tell you that this piece here is 11. What would the other piece be? 6. Right? That would leave this to be 6 so that the two pieces add together to be 17. That's the basic idea. Is that these two pieces of the segment, if I split a segment into two pieces, then those two pieces of the segment should add up to be the whole thing. And so that's what we're going to look at today. We're going to make it a little more complicated than that. But the idea, the fundamental idea, is not going to change. It's that the pieces of the segment should add up to be the whole thing. And we're going to call that the segment addition postulate. To be the whole thing. By the way, anytime if I'm going over notes that you do not have, then you can always go on to Canvas. Again, I posted an announcement yesterday that shows how to do this. If you go on to the modules page, there should be a place that shows the current chapter that we're on, and that'll give you the page, and it has any files or homework assignments or notes or anything else that you might need. So let me color code here. A to B is the first piece, and B to C is the second piece, and what I'm saying is that I can combine them together to make the whole thing A to C. It says the same thing that we said over here. That I can take these two pieces, combine them together, they make the whole thing. Okay. Let's look at some examples. So it's going to be a little bit more complicated because what I'm going to do is I'm going to give you some equations with x that we're going to need to solve. And the equations that we're going to get are going to be based or founded in the diagram that we have and the ideas of the diagram. So first example. What I want is for the two pieces to add up to be the whole thing. So let's see how that looks. Here are my two pieces. And the whole thing is labeled over here in blue, down below. It's drawn little bars to show that this means the whole thing, all the way from P to R, as opposed to just a piece. So the outline of what these equations should look like for these notes should always be I'm adding two pieces together to create a whole. My two pieces in this case, the first piece is the red one from P to Q. The next piece is the green one from Q to R. And then the whole thing is the length all the way from P to R. That's what the segment addition postulate tells me. If I take these two pieces, put them together, I get the whole thing. So I'm going to turn that into my equation. By plugging in the values that they give me for each of those lengths. Distance from P to Q, it describes as 2x minus 3. So I'm going to put 2x minus 3 here. And then I'm going to add it to the other piece, which in this case I see is 11. Take those two pieces, I add them together, I should get the whole thing, P to R. P to R is 3x plus 4. So that's what I put on the other side. And this is going to happen a lot in this class where you're going to have some equations that you need to set up and solve. But the key idea is that the equations should be founded The foundation of the equation should be in the diagram and the geometry ideas. You should be able to support what equation you're setting up. I should be able to ask, why did you add those two together? And you should be able to tell me, well, it's because those are the two pieces. So I add them together and make the whole thing. Let's solve it. Let's combine our terms. We've got a 2x minus 3 plus 11. Minus 3 plus 11, so I've got 2x there. Minus 3 plus 11, that means we're going to end up with a plus 8. 3x plus 4 is going to stay on the right. So just combining things together on the left side, combining things together on the right side. This is why we spent that first week working on solving the equations. Because hopefully we're refreshed on how to do that, and we're in a bit better shape here. So we're going to move everything with x to the same side. Remember, when I say move, what's really happening is that I am canceling. So the 2x's here, the reason I'm subtracting 2x is so that the 2x's on the left side can cancel, and I just have 0. So the only thing that's remaining on the left side is an 8. And then over on the right side, 3x minus 2x is a 1x plus 4. So then I've got adding on this side that I want to get rid of by subtracting. And I get x to be 8 minus 4 is 4. Something to keep in mind that you'll see me doing a lot is that you can always double check your answer. What was the idea that we based this equation on? It was the idea that the two pieces that we have should add up to be the whole thing. So let's see what we have. If x is 4, we can take 4 and put it in wherever there's an x. 2 times x is 4. Minus 3. Well, 2 times 4 is 8. Minus 3 is 5. That means I've got 5 as this piece and 11 as this other piece, which means the whole thing should be how much? If I got this piece is 5 and this piece is 11, what should the whole thing come out to be? It should be 16. 5 and 11 added together. The whole thing should be the two pieces added together. Let's double check and make sure that happens. 3 times x turns out to be 4 plus 4. And if we did it right, 3 times 4 is 12 plus 4. Hey, it's 16. And so that we know that we did it right because the geometry is working out the way that it should. The pieces are adding to make the whole thing just like they're supposed to. So remember, your equation should be based on an idea in geometry. The idea here today is that the pieces adding together make the whole. And then we can double check our answer by plugging in for x and making sure it works out that way. Next. Let's break out our pieces and color code them. I have L to M being the x plus 4. That's the first piece. The next piece is this little slice here, the 2x minus 13. So those are the pieces I want to add together. And when I add them together, then I should get the length of the whole thing, which is the entire distance from L to N. What is it? It's labeled in the diagram. If you don't know, these bars are showing, they're meant to show that we're doing each segment all the way from end to end, an entire thing instead of just a piece. So it is this length right here that's meant to stand for the whole thing. It's 12. So those pieces should add up to 12. What are the pieces? Well, the pieces are L to M and N to N. So we should add them together to be 12. L to M is x plus 4. M to N, this little piece here, is 2x minus 13. X and 2x, let's put those together. That's 3x. Plus 4 minus 13, that's going to be minus 9. And now solving that should be pretty straightforward. We just add 9 to both sides. Then I got 3x, which is 3 times x, so I'm going to undo that by dividing. So we get 7 for x on that one. And again, if we want to double check that it's working out the way it's supposed to, then let's plug it back in and double check that we're getting everything out properly. 7 and 4 is 11 here. So if this piece is 11 and the whole thing is 12, how far do we have to go to get to 12? Just 1. So this should be 1. I hope so. Let's put in 7. 2 times x is 7. Minus 13. 2 times 7 is 14. Minus 13 is, it's 1. Yes. We did it right. Because the two pieces, the 11 and the 1, are adding up to be the whole thing at 12. Just like it should. Okay, you'll notice that we jumped down to the bottom there. We're going to go back to those problems in the middle that we skipped now. Here we go. I skipped these ones because they're a little bit trickier. The reason they're a little bit trickier is because this time I did not tell you the diagram. I just described it to you. Which means we have to create it ourselves. Given B is between A and C. So we need to draw a diagram where B is between A and C. Let's do that. Since we want B to be somewhere in between, we're going to draw A and C first. So here's A, here's C, and we're going to connect them together to make A and C. And then we're going to put B in between them. Now when I say in between, it's not going to go exactly in the middle. We'll talk about later what happens when B is exactly in the middle. But for now, we're going to put it a little bit off center. So let's put it over there. That may not be exactly where B goes, but it's just to give you a visual that it's somewhere in between. And now we can label. A to B is x plus 2. So we're going to label A to B as x plus 2. A out to B. That's x plus 2. B to C is 3x plus 6. So there's B to C. I want to label it as 3x plus 6. Start at B, end at C. That's B to C. And then the whole thing, A to C, is 16. So starting at A, ending at C. I'm going to draw it out like that. Kind of like it did on the last page. It's just showing that we're labeling the whole thing and not just some piece. This whole thing is 16. And now we can set up our equation, which should involve adding some pieces to get the whole thing. I'll give you a 30-second head start and see if you can come up with the equation. The pieces are A to B, the x plus 2, and B to C, the 3x plus 6. And then A to C is the entire thing, so that's 16. I'm going to go a bit quicker for this equation, because hopefully we're comfortable with solving equations by now. I've got an x here and a 3x here being 4x. I got a 2 and 6 is 8 equals 16, so then I just need to subtract 8 from both sides. 16 minus 8 is 8. Divide by 4. 8 divided by 4 is 2. There's our final answer. Let's double check it. Moment of truth. A to B, 2 plus 2, oh, that's 4. And so, don't say out loud, but think in your head, what should this be if I want these two pieces to add to be 16? What should this come out to be if we're right? Let's find out. 3 times x is 2 plus 6. Here we go. 3 times 2 is 6, and 6 is 12. We did it. Fantastic. Because 4 and 12, the pieces add to be a total of 16. Again, keep in mind, this tells me that B should have probably wins the whole thing. That's what you want to be careful of. So I'm going to ask you to do the next one on your own. Start with a diagram. So it says F is between D and E, so make sure that whatever diagram you draw, F should be in between the other 2 points. D and E should be at the end. And then make sure you label each of the parts correctly. So you know which things are your pieces, which is your whole thing. Hopefully it looks like this. D and E should be at the ends. F should be somewhere in between. So in your equation, these are the 2 pieces that should be added. This should be the whole thing that you get on the right side. Answer, when you double check, the pieces should be 10 and 20 and add up to 30. You should get 3 for x.